Hello all, my team is Mark Home with the Hearing Impaired. Before I get much further, I'd like to introduce ourselves and our main contributions to the project.
I'm Henry Bright. I developed hardware and algorithms for smoke alarm detector and for a project.
And my name is Patrick Duong, and I was in charge of developing the door knocker sensor, developing the code for the Arduino hub, and basically designing the prototype for our proof of concept application.
And I'm Joshua Johnston, and the main goal with our project was to help the hearing impaired be able to better be aware of what's happening around the home. Sometimes their hearing aids are off, or the hearing aid doesn't pick up, for instance, an knock door or the smoke alarm. So we worked with two professors advising me to get that done, and the solution that we came up with was right now we have two main Arduino-based sensors. The first is a door knocker that's connected to a piezoelectric and an X-speed that communicates back to a hub, an Arduino hub. And then the other is a microphone sensor with a filtering circuit that samples a smoke alarm, compares it, and if it meets a certain threshold, it will send it out through the Wi-Fi network to our app on our phone. And specifically, the Arduino boards we use for the Uno and the Arduino Duo. Our application right now is in MIT's App Editor. It will vibrate and send a text, will bring up the text of the sensor that is detected. Native application using web languages and phone app is still on the go. The future of this project is planned to be able to integrate with existing systems, as well such as Bluetooth hearers and hearing aids, as well as it should be able to miniaturize and be even more cost effective. Right now it's very cost effective and not as cumbersome as what's on the market. We can demonstrate, we have a demo by our poster downstairs, or over by nature. And thank you all, and do you all have any questions? Yes?
Does your system distinguish between, say, the signal from the door or alarm from other things that may be happening in the room or in the house?
We've been trying to test whether, for instance, with a microphone sensor, in the lab, you know, whether a clap will register or the smoke alarm. And we do have some trouble with noise, although right now it usually picks up the smoke alarm accurately, or fairly accurately. Right now the system doesn't have any testing in the house, but for the future of the project we're hoping that it does get pushed and tested in the patient home.
Communication is through what?
It's communicated mainly through the home's Wi-Fi network. Yes?
So what kind of signal processing is done in order to identify whether the sound comes out of the smoke alarm, possibly distinguish between that and a clap, or how do you tackle that?
We mainly had in the Arduino sketches on the board, has some algorithms that compare to a known thing. We have a sample actually on the board that was comparing to.
Recorded segment of that sound, and you compare.
I think so. Henry, what exactly?
Yeah, so we've collected samples of the smoke alarm, for instance. Picked up, well, currently we're using about half of a period of that, just because of memory constraints on the Arduino. But yes, as signals are coming in, we're comparing. We're doing a convolution with the sampled signals and what we've previously recorded. Dividing that by the average of the collected samples, so as to create a fair threshold, you might say, of comparisons. And then we just said, okay, so if we meet this, if we meet a certain threshold, then we'll say that we'll detect this one.
And that works most of the time, but
Sometimes there are some noise issues, so we're hoping to make it more robust in the future.
So, what was the actual demonstration at the end of the project? What did you demonstrate?
We have our sensor with the XB connected to a door knocking rig, illustrated in the photo above, as well as we have the microphone circuit. We play recorded smoke alarm sound from a phone, and door knock, it's just if it detects voltage, it sends to the app and it brings up the texting vibration. And so we have those sensors by the toaster as well as with our, we set up a local Wi-Fi network and then we have our MIT app in their app on the phone.
So how much more work do you think that will work properly as you want to do?
We need to finish full development on a native application. Time frame is not exactly known because a lot of the materials has been learned this semester as we go. It could be a week, it could be a month. As far as the code to make the sensors more robust, I'm not exactly sure on the time frame on that. It does the algorithm for needs to filter out the noise a little bit more successfully. Yes.
How exactly do you plan to fix the noise issue?
It's a mainly, we believe, because we've had through our code several different iterations, different success levels. So we need to fix the code and their Arduino side and just try to filter out that sound and have more successful for comparing.
And I'll add to that, we're seeing about using, increasing the hardware, you might say, for the Arduino, so that we can use more samples than just half a period. Hopefully with a greater base of samples, that we can, we'll be able to have greater